Hello and welcome to part 4 of the trigonometric series. In this video, we're going to be focusing on the ASTC or the Aztec rule. What does it mean and how to use it? Okay, so let's start by defining what is the Aztec rule and trying to understand it. Okay, so the Aztec rule looks something like this. So I have an X and a Y plane, okay, which basically divides my area into 4 quadrants: this one, this one, this one, and this one. Okay, so the Aztec rule is spelled as ASTC. Okay, and each quadrant has a certain letter. So this first quadrant has a letter of A, meaning or standing for all, and I will go through this and I will let you know what does this mean in a second. Second quadrant stands for S, which means sine. This quadrant stands for T, which means tan, and this quadrant stands for C, which I think you can guess it means cosine. Okay, it's X and this is Y. And at the same time, this part over here, or this, is my 0 degrees, okay? And then going here, this is my 90 degrees. Continuing further, this is my 270, my 180 degrees. This is my 270 degrees, and coming back again, this will give me 360 degrees. Type all these are in radians. I can also write them in all these are in degrees. I can also write them in radians. So this is going to be 0 as well. This part here is going to be pi over 2. This part here is pi, okay, which is equivalent to 180. This part here is 3 pi over 2, and here we come to 360 degrees or 2 pi. Okay, so what does this mean? This quadrant, meaning all, stands for all of the 3 trigonometric series are positive when the angle is any angle between the zone. What do we mean? All is positive. Okay, so sine any angle from 0 to 90 or from 0 to pi over 2 is going to be positive, as well as tan, as well as cosine. Okay, this part, this quadrant, means that sine is the only positive thing, meaning that cosine here is negative and tan here is negative, and I will show you this in a second. This third one means that tan is only positive, so the other two are negative. Sine and cosine are negative when the angle is anything between 180 and 270 degrees. And in the last quadrant, if an angle is between 270 degrees and 360 degrees, only cosine of that angle will be positive, but the sine and the tan will be negative. Right. Let's take a look at this. Let's say we want to draw our functions. This becomes a straight line. Yes. Okay. Okay, so let's draw. Let's actually make it a little bit longer. Okay, so let's draw our sine curve, for example, first. Okay, so this is X, this is Y. We know our sine curve will look something like this. So I will have something like this that looks like my sine curve. This is one complete cycle, so I know that this is 0. This part here is 90 degrees. This here is 180 degrees. This part over here is 270 degrees, and this part here is 360 degrees. So let me do one thing. Let's take this and this. And do again over here, and let me draw these boundaries, let's say with the black line, so we know where is the 90 degrees. So this is the 90 degrees. Okay, here is the 180 degrees. This is the 270 degrees. boundary, and this here is the 360 degrees boundary. Okay, so let me try and draw my cosine curve now. So I know that cosine goes like this. So this is my cosine of x, this is y, this is my sine of x, okay? I know that this is 1, this is minus 1, just like that this is 1 and the other part is also minus 1, okay? I know that these are the same boundaries, so let's include them and draw our tan. Let me draw this and can extend this over here, this one as well, okay, and these two as well, to show you the boundaries that they're the same, so we can compare the boundary for each function. Okay, so let's draw our tan of x function. So we know that this is 90 degrees. Again, this is the 180 degrees, this is the 270 degrees, and this is the 360 degrees. Okay, so I know that my tan looks something like this. This is my tan of x, and I'm gonna draw only to 360 degrees, so my tan looks something like this. Like, what do I see from here? Okay, from my first quadrant, it says that any angle between 0 and 90, all of these functions are going to be positive. Let's see that. So any angle from 0 and 90, so let's say this angle over here, we can see that the sine is a positive value. Okay, the cosine for the same angle, let's say this is 30 degrees, 30 degrees, and for the tan as well, 30 degrees. I can see that any region between 0 and 90, any angle in this region will give me a positive value for all my three functions. So let's check the next region, which is from 90 to 180. What does my ASTC rule say? It says that only sine is going to be positive from any angle between 90 and 180. Let's take an angle as 100 degrees, for example. So 100, let's say, is about here. So I can confirm that my sine is positive. However, I can see that for the 100 degrees, my cosine now is a negative value, okay? And my tan as well for 100 degrees is a negative value. Similarly, let's compare the tan. So 180 to 270, it says that tan is supposed to be the only one positive. So let's say angle 200, okay? So 200 is around, let's say, here, okay? So I can confirm that my sine is going to give me a negative value at 200 degrees, which is in the third region. My cosine as well is going to give me a negative value, okay? And my tan is the only one that's going to give me a positive value. And as you can guess, we can do the same for the cosine. So 270 to 360, so let's say an angle of 300, let's say over here. So my sine is negative, however, my cosine is positive, and my tan is also negative for all angles in this region. So you can confirm that by getting your calculator, taking any angle. Okay, so let's say we need to do sine 100, okay, and then we do cosine 100 and tan 100. Let's compare those three values with so from our theory, the sine is the only angle that's supposed to give me a positive value. It's the only function that's supposed to give me a positive value when theta is 100. So I can confirm when doing this on the calculator, sine gave me 0.98, cosine gave me negative 0.15 or 17, negative 0.17, and tan gave me an answer of negative 5.67. So this is basically proving to you that the ASTC rule works and proving to you what do we mean by the ASTC rule. Okay, so I hope it's clear from now, and this is all theoretical. I want to move to practical. So how do we use the ASTC rule in order to solve equations? So let's try attempting this question together. Okay, so the question tells me that I need to find all the solutions of cosine theta equals to half from a region of negative 2 pi theta and until 2 pi. Okay, so now I know that I need to work with radians, right? Okay, so the first thing you should do is you should get the base angle. Okay, and we know all how to do this. Theta equals cosine inverse of half. So if I quickly set my calculator to radians and do shift cosine of half, the answer is going to be pi over 3. So pi over 3 is my base angle. Okay, so is this the only angle in this region that will give me a value, an answer of half? No. We need to find the other angles that when I put in cosine, they will give me a half as well within this region. And to do this, we will use the ASTC rule. So let me draw my ASTC rule quadrants. So A, S, T, and C. So let's analyze what do we have. First step is we need to look at our actual function. What do we need? We need a cosine of angle to give me a positive answer. So where is cosine going to be positive? It's going to be positive on the ASTC rule in only two quadrants, in the all quadrant, right? And in the cosine quadrant, because the cosine is negative here and negative here. We know that, and we just proved this graphically and using the calculator just now. Okay, so I want to tell you that using the ASTC quadrants, okay, going like this, so going counterclockwise is positive for the angle theta, okay, and going this way is negative angle. Okay, so if I'm gonna go from here to here, we know that this is 90, it's a positive 90, and if I'm gonna go from here to here, I know that this is a negative 90 angle. Okay, so basically clockwise is positive, anti-clockwise is positive, and clockwise is negative. So our first answer was pi over 3. Okay, and we know that pi over 3 is basically between 0 and pi over 2. Okay, so let's write our angles. We know that this is 0, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. So we know that pi over 3 is basically in this region, right? So we know that pi over 3, it's a positive angle, so I'm gonna go like this, and this is going to be my pi over 3 angle for my first solution. Okay, so this is my first solution, which I got using the calculator, which is pi over 3. In order to get the other solutions, I will need to always start from this x-axis direction and move until I hit my lines. Okay, so the first answer when I hit this line, so let me continue until I hit my second line. So this is the second answer. So this is my angle that will give me a value of half. طب how do I calculate this? طيب, I know that this is pi over 3, okay? And I know that this, if I extend this, okay, I know that this is also pi over 3, okay? And I know that also, using symmetry, that this is also pi over 3, okay? So this angle that I want to get is basically 2 pi subtracting this pi over 3, correct? Yes. So this angle is going to be 2 pi minus pi over 3 is going to give me minus pi over 3 is going to give me an answer of 5 over 3 pi. So this is my second answer. So 5 over 3 pi. Okay. Type. What else? Let's say I want to go to the next answer. Let me erase these. So if I want to go to the next answer, I'm going to start here. I can go all the way like this. And خلاص, I got this as 5 pi over 3. I'm going to continue until I hit this line. This whole rotation is basically a 2 pi rotation plus this angle, which is pi over 3. But doing so, 2 pi plus something, I'm going to go outside of my zone. So that's why I'm not going to take this as a solution and I'm going to erase it. Okay? Like, these are my positive solutions. So my positive solutions are 5 pi over 3 and pi over 3. Right. My range is from negative 2 pi to 2 pi. So let's check the negative solutions. Okay, so for the negative solutions, let's move clockwise. Okay, so let's start here and move clockwise. Okay, I know that this angle is pi over 3. Okay, so moving clockwise, so it's a negative answer, so my answer is going to be negative pi over 3. Okay. Continuing from here, my next solution is going to be all of this until I hit this part again, right? Which I will solve it in this way, where I know that this whole, if I completed this rotation, is going to be 2 pi. So it's basically a 2 pi rotation minus this angle right here, which is pi over 3, right? So my answer is going to be 2 pi minus pi over 3. This is going to give me a 2 pi minus 5 over 3. I know it's a 5 over 3 pi, and I moved clockwise, so my answer is going to be a negative 5 pi over 3. And to confirm that, let's check our answers. So our answers for theta are pi over 3, 5 pi over 3, negative pi over 3, and negative 5 pi over 3. I'm going to check each answer in the calculator. So 5 pi over 3, this is supposed to give me half if my solution is correct. And yes, it did, equals half. Like cosine 5 pi over 3. Let's check on the calculator. Cosine 5 pi over 3 also give me a half. And let's check cosine of negative pi over 3. This should give me a half as well. So cosine negative pi over 3 is also a half. And confirming that cosine 5 pi and negative 5 pi over 3 will also give me a half. So these are my 4 solutions within my range for this part. Okay, so just recapping quickly, in order to get the solutions, you need to move from the 0 line until your lines. So first thing we did was we got the base angle using shift cosine or cosine inverse of half. This gave me an angle of pi over 3 positive. So I know that moving positive to my first solution must be pi over 3. Okay, so if this is pi over 3, this angle is also pi over 3. I can also get this angle by doing pi over 2 minus pi over 3. This is going to be pi over 6 over 6, okay? And this as well is going to be pi over 6. So if I want my second solution, I will move all this way until I hit this part. So all this way is basically either 2 pi minus this part, or you can think of it as from here until here is 3 pi over 2, and then we need to add a pi over 6. So 3 pi over 2 adding a pi over 6. This will give me 3 over 2 plus 1 over 6 pi. This is going to give me also a 5 over 3 pi. So I know that my second solution is 5 pi over 3. These are the positive solutions because the next solution is going to be outside of my range. It's going to be more than 2 pi. So I stop for the positive solutions and I start doing the negative ones, which means that I will move clockwise direction. I will do the same. I will find the other two angles, and basically this is the solutions. Okay, in the next video we're gonna tackle other problems for the ASTC rule. Okay, ranging from moderate to harder questions, okay? And please stay tuned. Feel free to subscribe, like, and comment. Suggest any topics you would like to discuss or you would like me to do a video on. Please, again, don't forget the subscribe button, and thank you so much for watching. Hope this was beneficial.